Hi everyone, this is Catherine. I'm going to do a quick demonstration of my crypto Finder project. We have a secure message send application. This is a web-based Flask application with a SQLite backend. The Flask application has been configured and enabled with HTTPS. Users are able to log in, send encrypted messages to each other with AES and a shared key between the user and the server. Digital signatures are created from the message with the user's private key. And finally, the message is encrypted with the server's public key. So only the server's private key will be able to decrypt the message from the database. So let's begin. We've seeded the database with users 1, 2, and 3. The user password has been salted and hashed using bcrypt to make it harder to brute force, and also in case the database is compromised, passwords are in hashed form. We have some checks to verify that the login works. So our very first test is try to log in with an unknown user. So we'll just enter user 4. And hopefully we see an error. And great, we do. We see invalid data, goodbye. So our second test is to see if we enter a valid user and an invalid password. We should get an error again. Great, invalid data, goodbye. And then now if we enter a valid password for the user. 1pass is the password. And fantastic, we're able to log into the application. And this is the add new entry page, and it tells us enter your private message. We have a welcome message, welcome user 1. And then 2, this will be our recipient's ID. And then we're able to enter 2 forms of a message, either in plain text, and our application will encrypt it if we have this box checked off. And then if we want to enter only encrypted text along with its corresponding digital signature, we can do that. So let's try to enter hi to, let's meet at 6:30 p.m. tonight, and then try to do a send. And we actually have validation on the page too, so we can enter that. And then we also have validation on digital signature. So if we enter digital signature, even though this checkbox is enabled, we'll have an error. So let's just remove that, and we'll have 2, and then our message, and we should be able to send. Okay, so from the send, for the message itself, we'll have the plain text encrypted with AES and the user shared key, and then we'll encrypt again with RSA and the server's public key. And then the digital signature is a SHA-256 hash and signed with the user's private key. And this is actually what's stored in the database, and this is the same as if we click view entries. So we'll see that it's a match, the entry in the database here, and then digital signature matches here. So if we just do a view entries, we should see the same thing. Okay, and then we have 1 thank you for submitting your message, 1 message retrieved, and then messages in blue are sent by you. So if there is a message that was sent by you, we've color coded the row to be to be blue. And then if it's a message that you've received, it's in white, so you can just quickly scan for any white rows that will be relevant for you. So here we see this is from the database, and these columns are the user message and user digital signature. And these are the encrypted texts that will need to be decrypted with the user's local client. And our local client will emulate the decryption and signature validation. So from the database, the message was decrypted with RSA and the server's private key, which returns the AES encrypted message. And we take that message and decrypt with the sender's shared key. And then for the digital signature, we verify with the sender's public key. So once we have the encrypted message, everything looks good for the digital signature and for the encrypted message, what we'll do is take the final message and encrypt it with RSA and the user's public key. And then we'll return a digital signature SHA-256 assigned with a server's private key. So we can do that with view as requested entries. So we have a test page called view as requested entries. This is added only in our test regions and never appears in production. This simulates what the client decryption and signature verification would look like. Here we see that the message is decrypted with RSA and the user's private key. And then we have a digital signature. The SHA-256 PSS digital signature is validated with the server's public key. So that looks good. And we're able to decrypt the message properly. Now let's take a look at user 2 and see and just double check the message from their end. All right, now 2 and the password is 2pass, enter. So here we can do a view as requested entries, and we see that this is in white, a message that we receive. And most likely you'll just look for messages in white. And it says, hi to, let's meet at 6:30 tonight, and that's accurate. So now what we'll do is send a message to user 1, a new entry, and we'll send it to user 1. That sounds good. See you then. See you then. That sounds good. And then we'll send it, and we can view decrypted format here. That sounds good. See you then. And now we have 2 messages in our database. So let's log in as user 1 and just view our messages. So 1 pass. So we can do view entries, and we see, hey, this is a message that user 2 had sent. That sounds good. See you then. Great. And then this is our original message. Now let's try to do a send with the encrypted format. So we'll do open in new tab. And then we can do, we'll send it to user 2. Then we can do pick up the encrypted message that's stored in the database directly. And then we can pick up the digital signature. And typically it's anything in blue that you might have sent. Paste. And if we try to send, we get an error. We have to uncheck this box and send. Okay, and then we've sent it to user 2 from user 1. And then let's go and see if we can actually see it in user 2. View as requested. Hi, let's meet, and it's correctly decrypted in user 1's view. So let's log out. And we should have 3 messages in the database. User 2 and 2pass. And we'll view as requested entries, and we'll see the message in white, and hi to let's meet at 6:30 p.m. tonight, and that's accurate. And same thing, so we have 1, 2, and 3. Okay. All right, now what happens if, I want to show you what happens if we delete the private key of user 2. So let's go here. And then we'll just do a move of user 2 private key. So we'll do a MV 2, oops, 2, and then call it back. And then let's refresh our page. Okay, and then we actually see that when we try to view our user messages, we actually get an error for here, and then also anything here. Great. All right, and we'll see a user error, and then also let's double check user 1. So for any of the user 1 records, anything we receive from user 2 should say that we cannot decode. So let's log out. User 1 and 1 pass. Okay, oops, 1 pass. Okay, and we'll review the entries, and this is something that we sent. Right, so let's look for something in white, and then we cannot decode the message. Great. So now, now that we've correctly verified that that data isn't shown, let's take a look at our database also. So my database is a SQLite database, and it's called seeing extract.db. So let's do a cat extract.db pipe more. We could see that SQLite format. This is our table definition for the entry, the message. And then here's our table definition for our users. And then here's some of our initial user information. And then here is our information for the message entries. And we could see that the messages itself, they're encrypted. We don't see anything in plain text. Okay. And then, and that's it. All of the code is on GitHub. And thanks for watching this video. And please feel free to email me with any questions or comments. Thank you.